Hello, everybody. My name is Nikola Stjelja, and I'm an engineer in Philip Morris International. This talk is about how we started with Terraform and is very tightly aligned how we started doing our internal transformation of the company. So before I go into all of that, I just want to do a little bit an introduction of myself. So I'm from Croatia. I've been working for 13 years and I've been doing a lot of different stuff. And in Philip Morris, I basically worked for the last 3 years. In the beginning, around 5 years ago, Philip Morris was a very traditional enterprise corporation. We did not really have we had a strong IT, but we didn't have a lot of internal engineering experiences. We mostly outsourced that, and we relied on different vendors to sell us solutions. And then at the time, we basically started to change how we work. We started to basically create new products. And we realized that IT is a critical component to our success on the market and achieving our mission. One of the things that we basically wanted to do is to bring engineering back in the company. So I was one of the first engineers to be hired in the company after a long time period. And as Philip Morris does, we do things at scale. We're a big company, we operate worldwide, and we have a lot of people working internally. So we started to do this transformation, which is basically making the company more agile, flattening the hierarchical structure, and bring expertise back into the company. The project that I started in was a big commercial solution, which we're using to sell our new products worldwide, globally. And it was a big project. It had more than, I think, 150 people working. And times it was bigger and times it was smaller. People working in different countries, different continents actually. The system was composed of 40 different subsystems, and it was a huge solution. We differentiated the way we did the system internally. Previously, we did stuff in our data centers, in-house, on our physical servers that we actually owned. And we decided this one to go to the cloud, to leverage the power of AWS or different cloud solutions to accelerate our development and to reduce the amount of non-differentiating solutions that we have to develop. So what was the problem that we tried to solve? We wanted to create infrastructure scale. So we wanted to operate with a lot of subsystems. We wanted to create that infrastructure repeatedly, different environments, different on ad hoc solutions for experimentation. We wanted to operate across multiple clouds because we know that AWS, for example, is not present in Russia, right? We cannot operate with AWS in China. And we know that different regulations dictate which cloud solutions we can use. I wanted to leverage the power of infrastructure as code to really accelerate how we do all this development. As a company, we have auditing elements, which internal controls, we check what we are doing. And infrastructure as code, like making changes through code, really was something that we thought is going to really help us to have a controlled environment, an environment where we know that the change that we want to make was made for a specific business reason, and that it was controlled by a person other than the person who did the change, so that we have the right element quality and that we follow our IT processes. The problems we kind of faced at the time was that we did not know Terraform at all. Our team was composed of multiple people. So we had software engineers, we had DevOps engineers, we have people who were doing traditional system engineering, we had Salesforce developers, we had developers of different types in the team. And none of us really knew a lot about DevOps, so I'm applying like development practices to operations, and none of us had a clue how to do Terraform. And the project was big. It was distributed across multiple countries, across multiple teams. And we had to basically like learn how to do it. At the time, that was I think around three and a half years ago, there was not a lot of documentation on how to do Terraform. There was one book, there was one blog, and the practices that we found there help us get started, but they did not really work for us. So we had to learn how to use Terraform correctly, and with that, how to do infrastructure as code in an enterprise at scale in a distributed environment. And then we had to figure out what actually does not work. One of the first things that we tried was, okay, let's do a monorepo. We're going to have one team, one repo, and we're going to put our code there. And then we figured out that that did not really work for us. Why? The reason for that was that we were not working on one problem. We're not working on one single monolithic solution. Our solution, as architected, was composed of 40 separate projects managed by separate teams. In those projects, we had multiple moving parts, and we were working at different speeds. Secondly, we did not really know how we want to use Terraform. For some cases, having a monorepo work. For some cases, for some practices, it did not. So what we did, and what really worked for us, and we did it in a way that was not really mandated by architect team. It was not mandated by management. Terraform was a technology that was adopted by engineers. We did not really look at somebody telling us how to do it. We had to figure it ourselves. And so what we did, we had a lot of conversations. We did a lot of internal meetings, checks, discussions, arguments, and it was kind of like a grassroots approach. And we figured out that separating our code into small isolated repositories, which are basically changed only for one reason only, really work for us. And then with this experimentation, trial and error, we kind of figure out what works for us and what does not work for us. Terraform as a technology, one of the things that we really enjoyed was it was very well documented. So you may not have known the specific problem you were trying to solve, but you could easily learn it. And although we cannot use the same Terraform code between different cloud providers because the APIs and the providers change, the language and the ways of working is the same. So that kind of brought to us a certain level of confidence and quality in the solution that we did. And we kind of, at least in the core DevOps group, we figured out how Terraform should work. The problem we faced that a lot of the people in the organization did not really have that high level of enthusiasm about the technology. People liked it, people wanted to learn it, but adopting it at work was really hard for them, especially for people who never did anything related to infrastructure, or people who, for example, spend most of their career working as Salesforce developers or Salesforce operations. And we had to figure out a way how to scale it. And it was not something which was mandated by management. It was not something which was mandated by some architects, although we had architects working in a group, and it was a very, heterogeneous team of different people with different experiences. So we said, okay, let's do some trainings. And with Terraform, we did internal training, one-day workshop, and we did it several times with different people, and it took one day. And on that workshop, we covered all the basic elements you need to know, all the principles and practices you need to know to make sure that you can solve your problems. And we had people with zero experience in technology and practices who attended the workshop, and the next day they were productive. Now, it wasn't a good code from the beginning, and it was not really something, for example, I would have written, but they were able to move forward. And this is one of the reasons that engineers and Philip Morris really love HashiCorp products, because we really find that it's easy to solve problems consistently. And we started seeing Terraform being adopted by different teams across the organization, irrespectively of us. We started with this big project around 3 or 4 years ago. New projects started to fill different enterprise needs which were required by the new market and the new environment we found ourselves, and new teams were started from the ground up. So we had a lot of people coming to the company. And at that time, we did not really have one single channel where we all who were basically dealing with the same type of problem could communicate. So people started doing like the DevOps activities in islands. And after some time, we started having different enterprise sessions. We started talking to each other. We started figuring out what works, what doesn't work, what people are doing. And everything was fine. We started really getting the benefits of Terraform instructions code. We talked to other teams. They started doing the same things. But then we all started figuring out that we are hitting the same type of problems. Our initial ideas as a group did not really work all the time. So we figured out that managing passwords and credentials was not really a good scenario for Terraform. We figured out that using default provisioners to manage the configuration on a virtual machine on AWS was not really something the tool was good at, right? How do you refactor the code? How do you, when the reason and the way you change your solution change, how do you refactor Terraform code so you don't destroy production? Terraform destroy or making a change which basically drops the resource and creates a resource is not really something that you can sell to the management, the business. Say, yeah, sorry, I dropped our production because, well, I had to refactor my Terraform code. So we had to really start looking at these specific problems. One of the solutions that we also started taking a look was how do you test your code? How do you make sure that you, instead of doing manual testing, manual verification of infrastructure, that what you're doing works very well? And it took some time. It was not an easy process, and for some things we don't have an answer still, but we managed to figure out one practice, not a standard, a practice which worked for us in multiple cases. For managing VMs, we said, okay, we're not going to use Terraform for that. That's not what the tool was built for. We're going to use Ansible, and it worked. We had teams who actually use Ansible to manage their AWS accounts, and they said, nah, that's not really working for us. Okay, let's switch to Terraform. We created a GitOps-based approach, which was really simple. So we use Gitflow as a branching model. We use the Terraform plan and apply cycle to check the Terraform code, to check the changes. We attached those plans into our pull request, which we did using Bitbuckets and Jira's integration. So we had the Jira ticket, creates a branch. From that branch, you do a Terraform change, you do a plan, you attach it, somebody else reviews it, you merge it, the code gets applied automatically through Jenkins. And it took some time to build it. The most challenge was basically adopting CI as a standard across with Terraform. And but that started working. And with that, we started making changes very, very quickly. And as the business grew, as a product went live on production, and we started serving multiple markets, and each market had a different need, we really had to make infrastructure changes very quickly. And we really did not want to slow the business or our mostly development teams with the way we do infrastructure. So applying these practices, applying this tool, applying this way of sharing the knowledge inside the organization, how to do the tool, really helped us to accelerate the business. Really helped us to make changes quickly, consistently, and with good quality and speed. Now, we know that this is not, the end. This is not the end goal. This is not the only solution that we used. In PMI and different teams and different levels, product teams, infrastructure teams, use a lot of HashiCorp products, and we really like the open source elements of it. I've seen Packer is used. We use Vault. We use Console, and the consistency of the documentation and the quality of the solutions is really something that helped us basically adopt it very quickly. We looked at also writing Terraform modules for our purpose. for the cloud solutions which have a REST API but don't have a quality provider. And this is where we kind of hit a snag organizationally. For example, if you really, for us, we learned that if you really want to use Terraform for some solutions, we really have to have a very good and regularly updated Terraform provider for us to use it. We don't have in the organization Golang skills, which we hire for the purpose of working with Terraform. We have Golang skills. I basically spent 1 month writing a Terraform provider for New Relic just to see how it goes. And it's not hard, it's not easy, and it's not something as easy as writing an Ansible module, which is written in Python, and it has a very good documentation. So this is part which was struggling. And we said, we don't want to write modules. Right now, we don't see a business case for us to invest in people who are going to write that. And that basically also drives how we basically adopt Terraform across the entire landscape of the cloud solutions that we're doing. So if there is a good provider, we usually adopt Terraform. If there is not a good provider, we basically start looking at something else. The adoption of solutions is organic. So it was never driven by enterprise architecture. We're now coming into a point where we're consolidating across the application. We are having people at different levels having discussions, and Terraform is something that is part of our enterprise toolbox. At this moment, we are a hybrid cloud company. We operate a very large public cloud footprint where we provide standardized engineering platform for teams to don't focus on operations, focus on development, create solutions which differentiate our products on the market. We also provide a private cloud solution called SDI, where I'm actually working on. I moved away from the public cloud space, from the commercial platform into the private cloud team. We operate this solution across multiple regions. We have our data center, we have a lot of factories where we deploy this solution, which is serving as bedrock for our inference IoT product. The solution is based on VMware, and we see Terraform being adopted there. We see Terraform being adopted by the teams which are building solutions on a private cloud for the factory setting. They're using the VMware module for VRA, where people are able to codify their infrastructure, their machines, in the same way they would basically codify with AWS. We see teams which are basically doing two clouds, so they're using our private cloud SDI and AWS in the same configuration, so they're connecting the public cloud and the private cloud resources, which is really cool to see coming like natively in the organization. And inside the private cloud team, we're also using Terraform to codify our infrastructure. So we're deploying right now OpenShift clusters across the organization, across different regions that we operate in, and we're using Terraform to codify our base VMware infrastructure. So the technology is very present in the organization. We are using Packer for managing and creating virtual machines across the public and the private cloud. We use Vault for secret management, and very heavily starting to integrate with it and starting to leverage its solutions. And the biggest driver, at least how I see it, for that is the ease of adopting the technology. I would say that Terraform, but I think is also true for all the HashiCorp solutions, is like PHP. It's very easy to learn, but it is hard to master. So you can really start very quickly, and the documentation is so good and the tools are consistent and there is a good quality that you can really solve your problems very quickly. But you can write very crappy code and you can make a lot of mistakes, and those mistakes are sometimes hard to fix. So really how to spend time learning how to refactor the code, how to work with it, how to basically scale it. And this is basically something that is a pitfall of the technology, but I think it's inherited in the easiness of use. Well, thank you very much for listening to this call. If you want to have some questions, please ask them. Here's my LinkedIn profile. I'm always able to respond messages, and I hope you enjoyed the presentation.